It's chapter 351. It says a person going for a walk follows the path shown in the figure. The total trip consists of 4 straight line paths. At the end of the walk, what's the person's resultant displacement measured from the starting point? So let's review that displacement is a vector. So when they ask that, they're really asking for the magnitude and the direction. And so it says that you walk 100 meters to the right, and you walk 300 meters straight down, and then you walk 150 meters, and you have to be real careful with these angles here. So the length of these are 100, 300, and this is 150, and the angle they give you is the horizontal angle, which is this particular angle, so we'll say at 30 degrees. And then you walk 200 meters this way. I tried to draw the arrows with a length of the arrow corresponding to the magnitude of the vector. So the length of the arrow is how big it is, and in this particular angle is 60 degrees. And so what we want to do is we want to find this dotted line. This dotted line represents the resultant of all those. And so what I'm really doing, so I'm trying to find this resultant vector, and all I need to do is take my A plus my B plus C plus D. And how we do that is that we break them all down into pieces. So we want to look in the x direction. So just in the x direction we have 100 to the right, so that's positive. This 300 is straight down, so it's not going to play a role in a horizontal piece. And then both of these are left, so I'm going to do minus 150 cosine 30 minus 200 cosine of 60. And you get out your calculator and figure out that addition ends up being right around negative 129.9. And again, that's left. Take the vertical pieces. The 100 doesn't have a vertical piece, and then I'm going to take negative 300. And again, there's no sine or cosine with either of those because this was straight to the right and this was straight down. And then this has another down, so down 150 sine 30 tells you the vertical component of this vector, and then I'm going to add, because I'm going up, 200 sine of 60. When you add all this together, you get negative 201.8, which again said that your resultant vector was down. These two values represent the vertical and horizontal components of the resultant vector, meaning that dotted line. So someone else, instead of doing those 4 operations, could have just done that. And again, graphically, you're adding them tip to tail. So recombining those using the Pythagorean theorem, and essentially what I'm doing is I'm saying let's go left and let's go down, and I want to find that, and then I also want to find that angle. And so the length of those is just the Pythagorean theorem, and you should have gotten somewhere around 240 meters at 57.2 degrees. And you could say that is below the negative x-axis, you could say. You could say that it is 57 degrees south of west. I mean, there's a variety of ways to talk about that. But that's that problem.